So write and solve a linear inequality. Dave has $50 to spend. He can spend $18 on a hat and $10 on food. He also wishes to buy DVDs that are $5 each. So here's the information: $18 on a hat, $10 on food, $5 on a DVD, $5 on each DVD, and he's got $50 to spend. Well, if we write an expression for how much he has spent, or how much he spends $18 on the hat, he spends $10 on food, and he spends $5 times the number of DVDs he buys. So I'm going to write $5 times D. And what does he have? Well, what does he start with? He starts with, and this is also good to do. As we use this information and we represent it algebraically, we like to bam, cross it out, bam, cross it out, bam, cross it out. Okay, so he has $50 to spend. Well, this amount that he spends has to be less than or equal to $50. And these dollar signs look terrible, but these are all dollar signs. So we have 18 plus 10 is 28, and then we have 5D, which is the number of D is the number of DVDs. This has got to be less than 50, less than or equal to, I'm sorry. And then we have subtracting 28 from both sides, we get 5D has got to be less than or equal to 22, or D has to be less than or equal to 22 divided by 5, which is, if you go to your calculator, or you just, please, if you go to your calculator, you see this is 4.4. Well, in terms of DVDs, you really can't buy 0.4 DVD, so your final answer would be that D, the number of DVDs, has to be less than or equal to 4, because, like I said, we can't we can't buy a fraction of a DVD. So how would this look graphically? We would go here, draw a number line. We would label this DVDs. We'd find 0. We'd go to 4. Boom. So this is 1, 2, 3, 4. Now this is open as a closed dot because we can buy 4 DVDs. We can't buy 5, but we can buy 4, and we would shade everything to the left. And whoa, we can buy 0 DVDs, but we can't buy a negative number of DVDs. So that would be this. So let's be clear on that. These are all the possibilities of DVDs you could buy. As a matter of fact, it might be best to make this a discrete function, right? Because I said we can't buy fractions of DVDs. So to be clear, these would be all the DVDs he could buy. He could buy 0, he could buy 1, 2, 3, or 4. Okay. Explain the possible outcomes for the solution to a system of two equations and 2 variables. We've talked about this before. So let's just draw all the different ways we can draw 2 lines. We can have 2 lines that intersect at one point. So that's a possible outcome. 1 intersection. We can have parallel lines, which would be no intersection, which means no solution. Or, and this is another case, we could have 2 linear equations that happen to be the same line. So if they're the same line, where do 2 lines that are the same intersect? They intersect at every point along the line. So this is an infinite number of solutions. And let me give you an example of that real quick. What if we had 2, so example, we had 2x plus y is equal to 7, and we want to capture that same exact information. So if 2x plus y is equal to 7, 8x plus 4y is equal to 28. That's the same information. All I did was multiply the first equation by 4. Okay, use elimination to solve this system. Well, when we see this 3 and the 2 and the 5 and the 7, remember we're trying to do some kind of linear combination of these two equations to eliminate something. Eliminating eliminating y is going to require much bigger numbers, so let's look at eliminating x. So let's do 2 times the top equation, subtract 3 times, I shouldn't do it times like that, 2 times the top equation minus 3 times the bottom equation. So let's talk that through. We have 3 times 2 is 6 minus 3 times 2, which is 6x, so that's 0x. That's kind of why we set this up. Negative 5 times 2 is negative 10. So I'm just kind of distributing each one of these. So that's negative 10. Negative 7 times negative 3 is positive 21. So that's, I'll do that over the side here, and you have negative 10 plus 21, that's 11. And that's how many y's we have, plus 11y. And we have, here we have 2 times 10, which is 20, minus 9, which is 11. So that's 11. So you can just mental math this. 0 plus 11, y is equal to 11. That means y is equal to 1. That's the easiest elimination route you can take. And if y is equal to 1, we can go back to either one of these equations, look for the one that has smaller numbers. And, well, they're both pretty much the same in terms of complexity. But here we'll just go back to the, we'll take y is equal to 1 and put it into, I don't know, let's pick that one. So we have 2x minus 7 times 1, which is going to be just 7, is equal to 3. Add 7 to both sides, and we get 2x is equal to 10, x is equal to 5. So the point 5, 1 is our solution, let me just box this off here, is our solution to this system of linear equations right there. They intersect at the point 5, 1. And I have another minute. Identify the set of numbers to which 1/2 belongs. This, let me just draw all the numbers here, and all the numbers ever, almost all the numbers. So numbers look like this. We have whole numbers. Whole numbers are 0, 1, 2, etc. Then we have integers, which includes all the whole numbers and -1, -2, all those like that. Okay, so integers are the zeros. Then we have, to go a little farther, we have rational numbers. So rational, you look at that ratio, it means it's a fraction. So 1/2 or 0.333 infinitely repeating would be a rational number, because this is just 1/3. I don't know if I forgot any, but I guess there's natural numbers too. Natural numbers are 1, 2, 3. So I didn't include those in this picture, but 1/2, I just listed it right there, is a rational number. And it's a real number also. It has no imaginary component.